Sulfur S8. It's a non-metallic species or element, a non-metallic solid element at RTP from group 6, and with a chemical formula of S8. It's an octa-atomic molecule, naturally found in nature and also in metals, e.g. in zinc blende, galena, and copper pyrite. This is I would say, the structural formula of a molecule of sulfur. Allotropes of sulfur are two. There's rhombic, and there's also monoclinic sulfur. An allotropy is the existence of an element in many forms in the same physical state. Okay, so these are the two allotropes of sulfur, and I tried to draw the structures there briefly to just help us have a little bit of a bigger picture of what sulfur is. Both are crystalline in nature. Both monoclinic and rhombic sulfur are crystalline in nature. Physical properties: yellow crystalline solid at RTP, no test, and it boils at 444.75 degrees centigrade. Chemical properties: it exhibits oxidation states of -2, 0, +2, +4, and +6. Okay, it has got multiple oxidation states. It's more like a transition element, I think, on this one. So burns in air to form sulfur dioxide. Not a very nice gas. It forms acid rain, and it's very choking when you breathe it in because it forms nitrous acid. Therefore, the last point there is combines with many elements to form sulfides, like these guys here. Okay, like the guys up there. Uses of sulfur: 90% of sulfur is used to make sulfuric acid. Number 2, they are used to make rubber tougher in making tires. Okay, process called vulcanizing. Therefore, it's used in making rubber to be tougher, commonly used to make tires. In making drugs, in making matchstick heads. Okay, added to cement for making sulfur concrete. Concrete which is not attacked, which is resistant to acids. Sulfur dioxide, aka sulfur 4 oxide, okay, results from sulfur containing compounds burning in oxygen or air. Physical properties of sulfur dioxide: it's colorless, strong choking smell. As I said earlier on, it will actually choke you because it will form sulfurous acid on your throat and in the eyes and in the nose, wherever it's wet, because it dissolves in water. Denser than air, acid. It's an acidic oxide. Therefore, it forms acidic solutions with water. Soluble in water, forming sulfurous acid, which is this here, which can form in our eyes, noses, and everywhere where we are wet, like in the mouth. Turns damp blue litmus to red. Chemical properties of sulfur dioxide. Sulfur dioxide is one of the major pollutant gases, causes acid rain, okay, which can destroy a lot of plant and aquatic life, including terrestrial life. Sulfur dioxide plus water gives you an acidic solution of sulfurous acid. Sulfur dioxide plus hydrogen sulfide gives you sulfur and oxygen and water. Therefore, it reacts with sulfur hydroxide. Hydrogen sulfide reacts with sulfur dioxide to give you water and sulfur. Sodium hydroxide reacts with sulfur to give you sodium sulfite and water. Sodium sulfite and water. Those are the chemical properties of sulfur dioxide. Sulfur dioxide as a reducing agent, therefore, acts as a bleaching agent in aqueous solutions. Therefore, colored materials lose color or they fade when they lose oxygen. Okay, loss of oxygen is reduction. Therefore, it's a reducing agent. It bleaches. Number 2 there, the second point, reduces acidified potassium dichromate solution in which the chromium ion has a charge of +6 each to a solution of chromium with a charge of 3+ are present. Okay. Therefore, from orange to green. Let me repeat that one. Reduces acidified potassium dichromate solution in which the chromium ion is or maybe has a charge of 6+ each to a solution in which chromium gets to have a charge of this much. Okay. Therefore, the solution with chromium with this charge is orange, and the solution in which chromium has got this charge is green. Therefore, turns orange acidified potassium dichromate to green. The solution is as below. The equation is as below here. So, sulfur dioxide plus potassium dichromate giving plus these ions. Therefore, in the presence of an acid. Gives us these products here with this ion right there. The above equation represents the ID test for sulfur dioxide. Therefore, this is the identity test for sulfur dioxide. The last point there reads sulfur dioxide reduces purple potassium permanganate, okay, potassium permanganate to colorless. Therefore, it decolorizes the potassium permanganate. This is K, it's not X, it's K, just like potassium permanganate. It decolorizes potassium permanganate. It's purple and turns to colorless. The equation is as below here. So therefore, the potassium is left out. Therefore, we've got the manganate ion, water plus sulfur, giving us these products here. Therefore, in this reaction, the manganate ion, or the manganese, let me say manganese ion, has a charge of this much. And after the decolorization, the manganese ion gets to have a charge of 1 plus. Therefore, this is reduction from 7 to this. Therefore, it reduces potassium permanganate to simply being colorless. Okay. This marks the end of our short, brief talk about sulfur. I'll meet you in the other remaining parts of inorganic chemistry if there's any. Remember to subscribe and leave your comments down there. Bye bye.